Guys, welcome back. Let me just set up real quick. Sorry, got uh, in a rush here to set up. Just give me a second. Just need to unplug my phone real quick and dock it into this uh, grabber thing. Don't know what else to call it. It's like a little stand thing. Yeah, actually, I should also take off the case because this phone is gonna overheat. So let me just. All right. I apologize. I am not prepared for this. Delete that. All right. Sorry for the mess. Here we go. Yeah, sorry, I was in a rush to set up today. No big deal. So, should go on for a while, so a couple seconds here and there shouldn't matter too much. So, anyways, welcome back, everyone, to the Friday Open Studio Design Sessions. Again, if you're new around here, these sessions are weekly on Fridays at 5:30 p.m. And the intent of these live sessions is to really provide kind of a studio environment over the internet. So I'll be working on my projects during these streams, and you can be working on yours. That's kind of how I envision this to be. And so with that said, I know there's like nobody out there right now, but I'm gonna just go ahead and get started with today's session. So last week we started to really finalize the top half of this. This is the YX10 M1 prototype. We really started to finish up some of the paneling here. We added the nose cone here, which took a lot of effort. We finished off the bottom side here. You'll notice that this is not great, right? It kind of lifted off here. So we're gonna have to make some repairs today just to get started here. So we need to repair this panel piece. And I think there's like a tab of tape here just lifting off for no reason. So I need to fix that real quick. But yeah, a couple of repairs, and then we can go ahead and get started on a new aspect of this design, which are the landing gear system that I want to really develop and really make it work. So that said, there's not a lot of, I guess, background or logistics or anything today. I'm just gonna go ahead and get started. I'm just gonna free up this cable in this arm here. It's like jammed underneath. All right, there we go. This should be a lot better for the arm and for the cable. All right, so I'm gonna grab my materials here. So just Scotch tape off to the side. You have an X-Acto knife, really good for cleaning up different overlaps of tape and things like that. It's a nice sharp tool. Got a mechanical pencil here. You guys can't see all the tools, but it doesn't matter. But it's the same old tools that I have been using for a while now. All right, so we can get started here. All right, first thing I'm gonna do is fix up this little panel here. This little segment of tape just likes to come off for some reason. I think this was a newly added piece last time when we paneled the underside, and we're just gonna cover that up and secure that down so that it doesn't pop back up again. So yeah, so we finished paneling the bottom here last time, and this is also somewhere on the model that we need to repair. This is not that great. So I think we're gonna have to do some surgical work here, so to speak. Need to really lift off the old and attach it down again. I don't think that's enough either. We might have to wrap around to the top side to really secure it in place, because you know, the curvature here is, you know, it's slight, but it's more concentrated, right? So for a thin cardstock piece like this, it doesn't like to conform to that shape, so it'll tend to pop out and lift off this tape. So you have to really wrap it around to the top side of the fuselage to get it to stay, which I'm going to do right now. This should be the solution that we need. Yeah, so this will mechanically guarantee that it will not lift off. And do it again for this side, or for this little section here. I think for the rest, it should be fine because it's not too much of a curve here. So just one more. Right about here. Okay, so that's that. And so this one's going to be interesting because there's kind of a compound curve here. So I'm going to cut this down the middle here. All right, so that's that. I'm going to start with the side that lifted off, right? Just apply a ton of pressure here, a ton of tension in the panel, or in the piece of tape, right? To really structurally reinforce that and get it in place. Just really rub it in so it doesn't come off. And then you can do the same thing on the other side here. Same idea, right? And the cutting really makes it conform to this complex shape a lot better than if you didn't use that. You know, this looks all right so far. All right, so we did our repairs, and now it's looking like where we left off last time. I think I will have to at some point reinforce this area again a little bit more because it looks a little bit thin, right? And that might just because of all the layers up front here that, you know, contrast on this hard edge here. But I might have to reinforce this a little bit more, but we'll see. Don't want to add too much weight to this thing. So, okay, so that looks good. And now we can get started on the landing gear. So, you might be wondering why. Well, I mean, it's a hard question to answer, right? Because functionally at this scale, landing gear don't really do much, right? You can rely on the fuselage, you can rely on ventral fins to really dampen the impact, but that's kind of basic. And with this, we are just going all out. You know, it's just like to try different things, make experimental things, tinker around, really push the limits of what we can do. So that said, let's put our prototype aside here. I'm trying to actually design landing gear, which I was in the process of last time. Let me just grab the paper and stuff real quick. All right, so we have a blank sheet of paper here to get started. I actually have done 0 sketches or, just concepts for this landing gear mechanism. So today might just be a purely conceptual drawing day, but we might also throw in a little bit of prototyping, because that's usually how these design processes go. You just kind of come up with ideas, test them out, see if they work. If they don't, go back to the drawing board, things like that. So we're just gonna try and see what we come up with for landing gear systems. So for the landing gear, we really want to have a common part for all 3, I guess, landing gear. There's no other way to put it. So the nice thing about having a common mechanism is that you can try and repeat what you did before, right? And these back 2 are going to be symmetrical, but they're going to be mirrored across the longitudinal axis. So those 2 should be fairly decent. So I think we're going to start with the front landing gear to start with. So in our sketch, we determined that the landing gear fulcrum, the pivot point, would be about at the leading edge of the canard, right? So it would be right about here. So that's where we're going to constrain it. And then this is pretty much the length that we're allowed inside here. And then it has to come out, right? So I guess we can kind of write down our constraints here. We need it to be, so this is, what is this going to be? We're just going to label it YX10 M1 landing gear. Conceptual design. All right. This is probably the hardest part about, well, actually, concepts are easy. You can just draw stuff up real quick. Sorry about that. I know how to talk. But actually making it is the tough part, especially with parts that are this small. So we have existing methods or designs where we can make mechanical bearings and rotational bearings. So we'll leverage that. And I guess this is kind of a rough sketch here. So it's really interesting because I don't, you can, what's it called? You can, write down everything you want and then approach it in a very logical manner, but I'm not a very logical person. When it comes to these projects, again, like I always said, in my previous streams, I like to operate in between art and science, right? So this is I treat it as kind of a sculpture to me. And then when something doesn't work out, that's when I use the science and, materials and mechanics to figure out what's happening, right? So let's start off with a sketch of the fuselage that we do have, which is going to be kind of hard. Can't really hold it up in place, but you can imagine that you have your nose here, right? Your nose goes down like that, and then you have your canards here, and then your wing. Yeah, it goes up on the other side, but we want to build something that's like a really reinforced structure like that of some sort. Oh, that's not very descriptive, but this will be on the underside here of that fuselage. So fuselage really should look something like this. So again, we have erasers, we're drawing with a pencil, so this isn't permanent. And to be honest, I haven't drawn in a very long time. So this is a little bit difficult for me because it's been a while. Canards about here, your main wing about here, right, and then your tail surface about here. This isn't going to be exact, so that's not really the point, but we're saying that we want the fulcrum for the front one, front landing gear, to be right about here, right, something like that, and then it's going to fold in. Right, so this is about where we want it to be, and then it's going to fold in to this location here. So, I'm not sure. We need like a little fairing there to cover it up, or something like that. And then a wider thing here to really cover up the rest. So we have like a fuselage here that's open still, so we need to cover that up somehow. And there's going to be a structure there for that. But this mechanism is going to be interesting. So we have some methods of doing that. We can have a coil. All right, we can have the coil be something like that. Something like that, yep. So, just zoom in a little bit so you guys can see better. And then, so that's going to give it some surface area so that it doesn't wobble around too much. This is going to be wrapped around tightly, a centering component here that's going to wrap around. It's going to form kind of a loop on this end here. And then the other side is going to come around like this and then act as some type of stop, mechanical hard stop. So this will, I don't know what this angle will be yet, because that's determined by how much we want this piece to be kind of, I don't know, stationed? Is that the right word? Not sure. But it'll be interesting to see this mechanism in play. So essentially, we'll have, we'll have our center here, right? We'll have our landing gear that'll have its own loop on the end here, and then there will be on this side a piece that just goes like this or something. Yeah, that's the best I can come up with. And then once it comes out, this depends on how this thing moves, right? But eventually, your moved final position would be something like this, right? So this would hit the fuselage, just like the anchor there, and then you would have this dotted line, which is the landing gear here. Right, so this would move up like that to where the dotted line is, and then this would come down. And so you can make something like that to get started. Not really sure how else to approach this, but this was kind of the idea last time. It saves the most amount of volume and space, right? So you can do that to get started. Also need some type of spring to keep it open in the first place. So maybe from the side we have like a loop, right? And this comes out a little bit and wraps into that loop here. In your open position, you have something like this. Right, and then, that's your fuselage base. And this can actually, we can add like a little loop here. And then apply like kind of a spring elastic band to somewhere here. So that'll keep it retracted or open up, right? The real question is, how do we want this to look? Because that's obviously the most important bit of this design. We want it to look good. So let me see what we have here. Yeah, I think we might need a two-tiered kind of a fairing system. So something shallow like that then transitions into kind of a panel piece like that, and then it goes back. Yeah, this is going to be hard to model, but so from the front it kind of looks like this, right? Very slight movement, or very slight slope, holds the landing gear in place, and then this kind of spreads out. It goes backwards there. Just giving it flat sides here, but you get the idea. So some type of fairing like that. I'm not sure. This might be like a little bit wider, a little bit flatter. But we're gonna have to build it in. Okay. So that's kind of the idea so far. Maybe we can make this actually go like that. Who knows? I feel like that might actually be a little bit better. No, make it go like that. Because then, with a shape like that, then the rubber band on this center landing gear piece can wrap around these two, and then, it's in a stable position at the bottom of this little corner here. So, all right, I think we have a general idea. Now, the question is, how do we make it? All right, so I have some paper clips. Probably I'm gonna use this one. It's already kind of off. I have red, white, and blue. I don't have many white ones left, but since we're doing landing gear, I want the landing gear to match the trim color of the airplane. We're gonna use white for that. So white are gonna be the moving parts. And then, actually, I don't even know. I think we might be able to make 2 out of 1 paper clip depending on how we do it. And then the stationary parts can, this is just convention, so it doesn't really matter because it's the same. I can use orange here. Well, it's labeled as red, but it appears orange to me, so. Okay, so here we go. All right, so yeah, sorry if my stream is interrupted or anything. The, my phone overheats a little bit sometimes, so I'm not sure if it'll be interrupted, but if it is, and I can't come back into the stream, I'll start a new one and leave this one be. It'll upload by itself, but also I might be able to continue where I left off. So yeah, that's just YouTube in a nutshell. It's not very reliable, but it is what it is. All right, so you probably can't understand these sketches at all, so I'm gonna try and do a little bit more here before I start really prototyping with these paper clips. This is a pretty convoluted process of designing mechanically, precise moving pieces, right? So it's kind of like, I always liken myself to like a watchmaker of sorts. You're just crafting these mechanisms piece by piece, right? All right, so this is the first piece that we gotta make. I have no idea what the dimensions are, but we'll call this the kind of base, right? And then, so this is actually going to be flipped over, right? Something like that. And then, okay, so we're not going to draw it fully assembled. We're going to draw the pieces themselves. And then we have another piece here that is, all right, so we're going to have a loop here. It's going to come down. It's going to go off to the side, curve back in, go to the other side and curve back out, then continue on like that. This is the main landing gear leg, right? So this bend is going to ideally, this area right here is going to be inside that. Okay, so that's not actually very clear, but let me just draw another perspective here. So right? You have a little bit there, a little bit there, and it comes out here. Right, that's your landing gear. This is the part that the bearing here, the spring, this coil wraps around. So it's going to be locked in place by these bends here, so it doesn't, slide off, right? And then it can rotate about this axis. This is the part that moves. This is the part that's stationary. And then we're going to have like a rubber band here. We'll just label this as, well, not really labeling, but it acts as a spring. And then, that spring is going to wrap around this location here. So it's going to pull in tension. So yeah, I think, we have a good idea of what we want to do. Now it's just a matter of giving these parts numbers, like lengths. Because otherwise it's a little bit difficult. You should probably plan these things ahead. So, I don't know. Let's see, so that's about what we need. So again, this is like a little bit sculptural, right? It's not very precise. Also, I have a bad habit of switching between units, which is really not good. So, but it works for me, so as long as that's the case, we're all good. So I think 2.5 for the leg should be okay. So this would be 2.5 here, 2.5 centimeters, 2.5 cm, and then maybe like, I don't know, like 1 or so here coming off the base. No, that's not the length we want actually. The one we want is here. This is like 1. And then the width is probably going to be about 1. We might have to make multiple versions of this to kind of test out the fit and everything. And then this piece right here, this length here, is going to be probably this long. Probably 3. We need a pretty wide base to make this thing sturdy, right? So this is going to be 3 cm. It's going to be scaled pretty weirdly, and then this bend in and out. I think that can be like maybe 0.6 and then 1. Something. It doesn't have to be huge because it's going to be in tension most of the time. But yeah, we can even make this come out like that if we want. I don't think that's necessary. So, all right, let's get started here. How do we start making this thing? I think the easiest thing to start doing is making this base mechanism. You have this static part here. Okay, so we can just disassemble a paper clip real quick. I just use a ruler and then unfold it along this ruler. Use the absolute end here to pry it open a little bit. Okay. Okay. Looks decent. And then do it again. So this is likely going to be a little bit longer than what we need. So alright, so if this is longer than what we need, then we need to start at the middle to make sure we have enough on each side. Alright, so this is going to be a little bit bent, but I don't think that's going to be a huge deal. Right, This is just inevitable. This is a metal piece. It has a little bit of elasticity. It's hard to really make it a shape that you want without really crushing it, which I'm not a machine, so I cannot do that. So all right, so this is what we have to work with. You can start by measuring this. This is a little over 15. Let's see if this pencil marks it. Yeah, it does. 15 and 15 and a half. Wow, that's perfect. Okay, so half of 15 and a half is 17 and a half. No, not 7 and a half plus 0.25. So that's 7.75. Right? So actually it'd be easier to actually use a marker, a Sharpie for this. All right. 7.75 here. There we go. Oof. Yeah, that Sharpie smell really hit me there. It is kind of pungent. Anyways, I'm gonna check the comments real quick, see if anybody has any questions. Nope, no questions at all. Today is kind of a quiet day. You know, it's getting darker and darker, and as we approach winter solstice, so I expect people to want to go to sleep earlier and do other things, which is totally understandable. So, but we're gonna chug on here, continue on making our design. All right, so 7.5, and then if we want a midpoint here, and we want 1 centimeter width, so that means we need 0.5 to each side. So if we actually shift it a little bit, makes it a little bit easier to see that. Well, we can't actually, yeah, we can't do that because it's actually wire that's wrapped around, so the length is actually going to be varying because it's a helical spiral. So, and I don't really want to do the math for that, so we're just going to start to coil this orange piece. But before we do that, we need a sample white piece. I mean, it's the same wire, it's just colored differently. Just gotta get a different piece to wrap around to get that nice tight coil shape. This coil shape is pretty interesting. I actually did not invent it, even though I put it into use in this aircraft design. I actually saw it off of some guys tinkering on Reddit. I was like, hey, that actually does exactly what I need it to do. You know? And then I was like, all right, cool. So I can use this system to create rotational linear bearings, or, bearings in general. I'm sure it can act as a linear bearing as well. Bearing is essentially something that holds something else in place and then allows movement within something. I mean, it sounds pretty complicated, but it enables pretty cool things like, moving control surfaces, right? So like your little canards here in the front, they get to move once you push this rod back and forth here. So things like that. Yeah, I tend to find moving things to be really interesting. Right, there's like an appeal to mechanical watches, right? And there's like this wondrous quality about them. It's like it's all springs and pure engineering and design, and there's no computers or anything at all, and it still keeps time pretty accurately. Granted, I'm wearing like an Apple Watch, which is a electronic watch, which is more precise and more accurate than mechanical watches, but there is definitely an appeal to mechanical watches, which I think maybe in a past life I was like a watchmaker or something. I like these really intricate mechanisms, and they're kind of I don't know, it's like there's an appeal to them, right? So you have these like channels on YouTube. I recently subscribed to this guy. He's a Vietnamese, I think he's formerly a professor. I don't want to be incorrect, but I might be wrong on this, but he was like an engineering faculty at some university, retired of course nowadays, but he makes these really cool animations on YouTube, um, of different mechanisms that he designs and animates in CAD, which is super fascinating to me. I think his like channel is like Thang, like THANG, and then I don't remember the rest of the name, but he's like super popular. He makes like these short 40-second videos where he animates these mechanisms, and it's just incredibly satisfying to watch everything just work. It might not be like physically possible to manufacture or really get into use, but it's very cool to see conceptually come to life here. So, all right, so I'm gonna wrap this orange piece around this white piece here, get the coil started. I think we have more than enough on each side to create this mechanism, so we're just gonna go ahead and go for it. So this is kind of the hard bit, is getting started here. I might actually need some pliers, which I'm gonna have to grab real quick here. So this is my this is my this is my little device that I use to appear online. The weight of this pliers exerted on that eraser on the keyboard, it just keeps it active the whole time. So I'd appear online at work, on Link, Skype, things like that. But anyways, that aside, this is the first bend is the hardest because it's you don't have any support material to grab onto, so you're just gonna have to use a pair of pliers or whatever you have really get started. Okay, so we have that, and I'll just wrap this around this white piece here. So that's kind of the process, right? You start a bend somewhere, preferably close to the middle, and then you just God, this is difficult because like when you apply too much force, it likes to spread apart like that, and it's kind of hard to control, but you just gotta try your best to compress it together and get it to fold. Right, so once it's looking like this, it's a little bit easier. I'm gonna zoom in a little bit for you guys. This is a little bit easier at this point because you have a lot of leverage, right? I'm just curious where so the black dot is right here. This is why you need to have plenty of margin on each side. It's that this the center might not be at the center anymore because of shifting around, and you're finessing with this very thin steel wire. It's just a little bit cumbersome, but you get used to it. And this is really the best thing about this design, is that it creates this very stable mechanism. Once the coil is made, the piece in the middle is able to rotate very nicely. It's like very smooth, and it's hard to describe. It just feels really good to actuate. So this like, I don't know, this is gonna sound weird, but if you're into cars, it's like driving a German car like an Audi or something compared to something like a Prius, which I drive. So it's there's a difference in the quality of the movement. So we're just trying to wrap this thing around here and create the landing gear system. So this is going to be a little bit challenging here because this coil is a little bit too big. So we need to compress one of the sides down. And that always yields in some irregularities. So I'm just going to try our best here. And really, this isn't going to be perfect, right? I'm no machine. I am just an old-fashioned craftsman here, tinkering away. But you just got to try your best and put your best effort in. It's always the attitude I have about these things. And then, all right, so this looks good. All right, so this is really freaking tight. It's really hard to get this thing to compress down even further. It's really the first couple of loops that are really difficult. I've said that before. So, right, so we want, you see this little gap here at the top? Yeah, we don't want that gap. We want this to wrap around even more tightly. That's why this is really difficult. It's very timely to make these things. I'm sure you can like buy pre-made hinges and parts, but it's like, first of all, it takes like forever to ship from China. And second of all, it might be cheap, but still, I want these projects to be pretty accessible to anyone who wants to put in the effort and doesn't want to order anything online, right? These are made out of paper clips, they're made out of paper, right? You can make some pretty cool stuff out of some very basic materials, and that's kind of been the philosophy behind most of my projects. So this is going to be a little tough, but I really hate doing that because it kind of strips away the rubber coating on these steel paper clips. You really want to keep that coating because it's good for adding a little bit of friction to the mechanism so that it acts a little bit more stably. Stably? Is that even a word? I swear, like sometimes I don't even know how to talk. It's like, it's a Friday afternoon. I always hold these design sessions, open studio sessions on Friday afternoons, and it's just, I'm always a little bit too tired to properly speak. But look at that. You just slowly get there, right? So you just need to compress that down a little bit. Yeah. Yeah, you just gotta be careful because with pliers, sometimes you exert too much force and you might like make it a little bit too small where the loop is like pinching onto this axle. So you just want to be a little bit careful there. But it does do a great job at evening out the shape, right? So this is a lot better, right? These three are parallel. The edges are lined up with each other. It's a very, very precise thing, but you gotta make sure that it is precise because otherwise it's just not gonna behave as nicely as it would. Okay, so I'm going to continue wrapping this around until we get 1 centimeter of oh shoot, yeah, so that's another bit here. You don't want the axle to bend either. So ideally, it would not be in the middle. It would be near one of the ends here so that it doesn't bend too much. And then, yeah, there we go. That's a lot better. Yep, and see, it gets faster and faster as you continue this process. Okay, so this side is a little bit short, so I'm gonna wrap on this side. All right, so when it spreads apart like that, you want to kind of clamp it back down. So you gotta be careful here not to clamp your fingers, but you can squeeze it back together a little bit. Right, and then just keep on turning this piece around, this white piece here. I think that's enough for us. So we're gonna finish off there. This is exactly the same design as the core of the friction, or of the CSAM, the control surface actuation mechanism design for the, for this plane right here. So how this little wing in the front moves is, the inside is pretty much exactly the same as what we have here. Oh god, so it's a little bit tight. So what we want to do right now, just thread this through real quick. Actually, you could use this end as well. There's no issue to that. So it's a little bit frictiony, which is good. It's a little bit tight. So I'll just put a bend here so that I have more leverage, so it doesn't rotate with me. I'm going to now grab this and bend it out a little bit. And the reason for this, it's a very slight detail. And again, with these mechanisms, it's all about the details, right? You want to have a centered component. Okay, actually, maybe not for this, but normally when you want it to be in line, like a coil like this, right, to be like that, you can't actually get that to happen, right, because it's a 3D object. It comes out of the page. This circle is larger than the wire itself. So what you need to do is apply a little bend here and then have it go straight, right? And so that's what I'm doing. But I actually realized we don't really need to do that here because this is kind of the structure that we want. So there will be a little bend on one side to compensate because of, just asymmetry, but we need it to come down approximately 1 centimeter. So we can go ahead and do that. Actually, you need to, in that case, we need to correct this, fix that bend back. Just gotta compress this a little bit and bend it back. All right, so, yep, I think this is wide enough of a fulcrum for the landing gear, right? Actually, if I try and dry fit this, it's about the length of this panel here, so that's about right. Of course, this will do some other things, right? So it's not going to be full length like that, but if we place it on the actual fuselage, it looks decent. Doesn't look like it'll not fit or anything, so that's good. Just gonna check for comments real quick. Friday the 13th build, hell yeah, I'm going all the way. Yeah, it is Friday the 13th, but I'm not superstitious. I'm only a little bit stitious. Anyways, that's a joke from The Office, if you watch that show. All right, so okay, so this is looking good. The only thing I'm a little bit concerned about is this, I guess, the angle here. And then just making sure that this is precise enough. All right, I think we're good on that front. We can start marking up the locations where we want to make bends. So we can start with one side. Just honestly, it doesn't really matter which side. just gonna have to make compensations anyway for the other side. Whichever side you pick. Right, just do one like that. This is the 1 cm mark. I'm not sure, that might actually be a little bit too much, but we'll see. I feel like that is a little bit too much. You measure 1 cm from the back end of the coil there. Alright, so that's the offset 1 cm. Sorry, this is like super boring. This is like, we're getting into the weeds of this mechanism here. So if it's too boring, then just click away. You're not obligated to watch, but I feel like you guys might get something out of this. Again, these are open studio sessions, so you can also work on your own projects too. Alright, so I'm gonna push this down a little bit. Bend this out. Okay, it looks decent. I'm just gonna pull this white axle out. Alright, so I think we're gonna go with that. So the black mark, the border of that black mark, I am clamping that down. And then we're gonna make a 90-degree fold. Actually, that's interesting. If this isn't 90 degrees, could I save some material, save some space? Because if I make it go diagonal like that, that'll save a little bit of material. Interesting. I'm not sure. If that's the case, then I don't know. What angle should we do? 45? Do 45. I think this, if you put it at an angle, it'll look a little bit sleeker and it doesn't have to sit as high. I don't know. Also, it can move a little bit more than usual. So if you put it at a 45 degrees angle, it's a little bit compressible, right? So it can rotate a little bit more than if you did like a pure 90-degree angle. So I'm not actually sure. This is the first time I've actually built this design out. It's always been like these random scribbles and sketches. So they might not look great here, but these aren't art pieces. These are just concept sketches to get me going, prototyping. Yeah, I feel like a 45-degree bend might be best. It'll help with the shock absorbing characteristics a little bit. Oh shoot, yeah, just need to bend that down a little bit more. So that's the one problem with this thing, it's rotating out of plane. What I mean is, if you look at this, it's like bent outwards, right? Instead of this being like perfectly perpendicular, it's bent outwards a little bit, which is unlucky. Alright, we can fix that, we can rotate that back in. Did that fix it? Yeah, it fixed most of it. Okay. And then, alright, we just want to get this one to appear the same here in terms of the bend. Alright, so we're gonna have to bend this a little bit more. hold this down, bend it as well. So it's going to be a slight bend just to see if the corners are matching first. I think they are. So match up the corners like that, and then you can apply a steeper bend, more confident bend into this. The whole reason that we need to do that is there is an offset between the two sides, right? If you look, there's a little gap, so you need to account for that. So, but I think this should be good for the most part now. It's not the most beautiful thing, but it's a result of geometry, so I can't really fix that. Also, both of these are a little bit skewed. They're like not perpendicular, so I need to change that. There we go. Sorry, I was off camera a little bit there. There we go. A little bit better. Okay. I can say that, you know, both of these are decent. Okay, so this is still a little bit off in the sense that it has to come out a little bit, but no matter. I'm gonna mark the baseline here. So this black dot is where both are gonna start in terms of the geometry that happens after this bend. Is all gonna start on this line, so it's gonna be equidistant. It's gonna be good. Okay. All right, so it's gonna look like this, and then like a 3 centimeter bit. I don't think it needs to be 3 centimeters at this point because we're doing a 45-degree thing. All right, so what I think I'm gonna do is actually change this geometry up a little bit. So this isn't gonna be 3 anymore. This is probably gonna be like 1.5 to 2.5, somewhere in that range. And then the shape is gonna be like this, and it's just gonna end there. So this is gonna be a pretty steep location for the rubber band to really sit tight into. And then, I don't know, maybe if we have leftover, we can close this off, but that's not really necessary. That's not strictly necessary. Okay, just checking the comments real quick. Nope, no new comments. All right. Okay, so this is good. What are we gonna do? Yeah. So how much do we need? That's the real question. If we center this pivot point, we only need to go about here. That's a decent measurement, right? How much is that? That's about 2 centimeters. Okay, so 2 centimeters behind this black dot. That's a good number. Actually, 2 is exactly in the middle of these two numbers. Wow. I have a very good sense of intuition for this thing. Anyways, I'm just patting myself on the back at this point. So enough of that. Let's just do that mark it out here. It's going to be at 2 centimeters. Shoot. Okay. Okay, so 2 centimeters will get us right about here. And then 2 centimeters on this side, and right about there as well. See if they match up. They roughly do match up. Maybe this dot needs to be a little bit higher, but very close to where it needs to be. Okay. Okay, and then okay. We need to bend it in and then out again. That's alright, that's gonna be a pretty tight thing. Alright, I don't think this is going to be 2 centimeters nominal anymore because this black dot is a little bit in here. Yeah, I don't want to bend this back out because that'll weaken the metal, right? It's called fatigue. Yeah, you really don't want to be bending metal too much if you don't want it to break. If you want it to break, then great, go for it, but I don't want it to break, so. I don't think we can do a Z-bend. It's going to be a little bit tight, but we can definitely do something like this and bend that out, so. All right, so at least I'm consistent, right? There we go. There's small, intricate parts. You just gotta have patience here. Okay, that looks decent. I'm just gonna increase the tightness of this fold a little bit on each side before I apply a bend backwards. Yeah, this is going to be a little tough. I'm going to need my second pair of pliers. And try and get this to This is tough. This is what happens when you design parts with so many tight bends. It becomes pretty near impossible to actually make work. Just correcting some minor geometry mistakes here. Probably would have been easier to fold this outer bit first. And then, yeah. Huh. All right. I'm just gonna try our best here. Do what we can. We don't even need both. We only need one to make it across, so to speak. Right? We only need one bend back, one side to do that. We don't need both, but both would be nice. So I think to do that, we need to probably open this a little bit. Get our hefty pliers in. And bend this out. Oh my god, you gotta be careful not to hurt yourself. Like I almost did. All right, I think, you know, actually this is, I want to say this is enough, but honestly at the same time, I'm just so close. This is so close to being completed. Yeah, might as well put in the effort. Complete this little piece here. This is a pretty complex piece, simply due to the amount of folds needed to finish this off. I mean, this could function right now, it's not very clean. Just want to clean that mechanism up a little bit. Or clean that design up. It's not quite a mechanism yet. There we go. Oh my god, that took so long. Alright, and then now, after we got that fold in, we can now collapse this coil a little bit more. But damn, if this thing works, I'm gonna be so surprised. I honestly did not expect this to work. You know, I do not know if these things will work because this is the first time I'm ever making it, but we're taking a precise, exacting approach, right, to make a thing that might eventually become part of my design portfolio, which is to say, you know, I'm not submitting it to any school or anything, but it's like a design that you can use in the future to reference, right? All right, sorry there. Had to take a sip. I gotta stay caffeinated during these things. All right, same idea here. So we're gonna borrow a little bit of width. We are going to fix it. We're going to bend it back, but for now, to borrow a little bit more here. All right, so we got that bend to go. And then I'm gonna compress this in a little bit to get a little bit more clearance there. Nope, wrong idea. All right, move that back out a little bit. Yeah, I don't want to clamp both of these down at the same time because that'll create a dent on this outer piece. So ouch. That's why people have fingernails, because our ancestors are craftsmen and hunter-gatherers. You need nails for that. You don't want your finger to be ruined. Ooh, there we go. Got it. Now it's gonna be just a matter of slowly getting it to the proper shape that we want. Do that. And actually, I just grab this tip here and then this tip here. And bend it a little bit more. Just making sure to check every now and then where it is. Oh, yeah, see, that's why you gotta be careful. And then slowly but surely we will get there. This takes such a long time to make. Time is one thing that we do have here. Because we are tinkering. This is like a hobby, so. All right. That's pretty good. Actually, we didn't even have to cut anything. That's how good this piece is. We didn't have to cut any extra wire. We just kind of folded it all into this little piece here. So this is gonna fit in right about here. It looks pretty good, looks pretty clean. Now I just need to get our landing gear piece done. I say that like it's nothing, but it's actually gonna be so much effort. But yeah, this will be taped down. And yeah, we'll assemble it later, but for now we need to continue with our journey of making a landing gear piece. Alright, yeah, so this, you see all that damage on my nail? That's from working with wires, steel wires. It's a very stubborn material, but you gotta be more stubborn than a stubborn material to make it work. I'm just gonna make some minor geometry corrections to the legs here, the base of the static piece. Okay, so this can actually be compressed a little bit closer together. Compress. Okay, looks pretty decent. This spins nicely. Now the question is, okay, so this is the front. Is this enough to wrap around here and then create a little leg? My gut feeling is no, so we're gonna have to bend this back out. This isn't like a super tight bend, so we can actually afford to do this this should be enough. This should definitely be enough. All right, so I'm gonna do that. This is based on gut feel. Again, if this doesn't work out, we can always take this part off and then redesign it. But this piece is the core of the mechanism here. Oh my god, go in already. So how tough is this thing? Oh my god. Alright, yeah. Come on, go in. There we go. All it needed was a little bit steeper of a angle so I could push it in. So this is gonna go like that. I think this one, oh shoot, I should have put it in the other way. So my channel, when I make videos and take photos, I usually take photos of the aircraft from the left side. So this is like a very small detail that you probably don't even care about, but I care about. I want the leg to be, the landing gear to extend out on the left side so that I can take a nice photo and capture that nice bar coming down. And the only way to do that is if I make it like that. So now this long end here, when this is attached to the bottom of the fuselage, this long piece here will become the landing gear, right? So it takes the foreground, it's not in the background. So it's a very small detail, but I want to do that, so here we go. That answers your question. You guys don't even have any questions, so whatever. Whatever. But yeah, we do need this to be hold this in place. And then bend the heck out of this thing. Yeah, this is an initial concept. This might not even work. But damn, I hope it works. Bring it out a little bit. Make this go in the center. So it'll come out like this, right? Something like that. Yeah. You know, that doesn't look half bad for a very first prototype. That's not bad at all. course, we'll have to complete the leg, but this captures the general idea here. So when the landing gear comes out like that, this needs to be up here. Okay, so we gotta get it at the angle that we want. Honestly, we might not even incorporate landing gear into this design. Might just finish this off as is, but we want to test out if it's possible, so that's why we're doing this right now. Let's zoom out a little bit. This is kind of how it looks like attached to the fuselage here. Just thinking about this. Right. So if we attach it here, let's zoom out even more. This is how it's going to look. Let's focus in here. Just fix this a little bit. And a lot of this is visualization, so this is a little bit boring. I apologize, but you gotta think these things through. So something like that. keep it straight. If I keep this thing bent on the same plane here, that makes it straight so that the angle is directly related to the leg. I'm gonna call like the part that interfaces with the ground the leg. So if we want the leg, oh, we can actually tune it because this is steel, right? We can actually tune it later. So I think a good place to start would be to make this bend for white here and then go back here, right? Extend out a little bit. So that's where we're gonna start. This is gonna be very tight. Oh my goodness. I don't even know if is this even possible? Like, this would be such a tight piece. Is it even gonna be able to move afterwards? Make sure I did not distort the base here. Okay, here we go. Just need to twist it a little bit every now and then. And then this would be on the same plane now. God, this is so hard. All right, there we go. Oh, what do you know? We got it to work. It's just a matter of aligning it. Right, this is looking like a pretty good mechanical piece. Look at that movement. That is so smooth. And it's locked into place so it won't slide off, right? Look at that. That is so intricate. I'm kind of proud of this. Even if this doesn't end up being used, I'm pretty proud of this piece right here. So the idea is that once we create this loop, we can use a, okay, this is too large, but my point still stands. You can use an elastic band to pull this linkage arm, this white linkage arm backwards. And what that does is, it keeps this landing gear in a deployed state, right? So there's going to be a hard stop, right, with the fuselage here. So that's why we need to adjust this length. But it's going to enable pretension so that the landing gear always wants to stay open. And when we don't want to use it, we can close it in and then use a hatch to lock it in place, right? So that's kind of the idea here. behind this design. And so far, it actually, it's not that bad. It actually works. Well, so far it's not a whole landing gear system. So far it's just a couple of parts cobbled together, but the idea is there. The the roots, the base foundation of this mechanism is there, so that's good. So I do need to make some geometric corrections here to account for this curvature. So, but look at that, right? Once we fit this on the bottom here, this piece will rotate and then deploy landing gear. We just need to make this bit shorter, right? And the way to do that, I think, I really don't like to cut these metal pieces, because once you cut it with this wire cutter here, right? Once you cut it, you get this very sharp, like a flathead almost shape. And that is dangerous because you can cut yourself really easily on that. So I tend not to do that. Try to avoid cutting whenever possible. But this is looking good. I might want to try and adjust this fulcrum a little bit more, but I doubt it's gonna make a huge difference here. Yeah, because honestly, this hinge and the base, it's because it's a helix, right? It's a helical spiral. There's an offset angle to the way it sits, right? So you need to compensate for that, and it's kind of hard to do that, get it to work. So unfortunately, I'm not sure if I can actually correct for that. It's just very finicky like that. You just gotta be careful. There's a lot of variability in this mechanism because I'm not a machine. I'm making this by hand. So I always say that as my crutch for imperfection. But it is true. I am not a machine. So, so this is a little bit off axis, but we'll fix that last. We just need to fix the base first here. Okay, so yeah, this is just gotta pinch that. Oh, all right, that's not good. Yeah, you gotta be careful not to damage these pieces. Alright, so the only thing that I see here that is an issue is that this is clamped too tight. So that will not allow us to wrap an elastic band around this. Damn it. God, this is damn near impossible to fix. Alright, so I get more leverage, so you gotta grab at the end here. Yeah, my fingers were vibrating because it's a lot of force that you're exerting here, but all right, it looks good. Just fold that in a little bit. I think that looks pretty good for the most part. If you try aligning it again, I think it looks okay. So we need a little bit more bend here. This is the art of wire bending, so to speak. Right? You have moving pieces that you want to get precise, and you have a material that's elastic, so it's a bunch of tiny adjustments that add up to this cohesive whole here. So this is kind of the landing gear where it's going to sit, right? Where it's going to be taped on the space, and then all right, so for this, I'm thinking, since we want an angle like that, it might be good to bend this out. Yeah, I'm just gonna fix that slight bend in there. Okay, so this is kind of what we have right now. Right, this little piece right here. And then once we bend this out, actually that acts as kind of like a shield over this coil. I don't know why. You don't need, it's not like a functional thing, but it just looks very secure. But that's like hand wavy. You could argue that it doesn't, but I don't know. So less means steeper, right? If you give it more angle or more length, that means a shallower angle. So it depends on how we want it to look, because quite honestly, this is not a functional piece. This is like a aesthetic piece, the landing gear. So I think this is about good. So that means we need to get it to bend over right about there. And this doesn't need to be a loop, right? So this is literally only to secure the rubber band in place, the little elastic band that we're gonna use. This actually allows us to see, visualize where it's gonna be, how it's gonna act, right? So this is our landing gear right now. I think that's a decent angle. Might be a little bit too not deployed out enough. This is good for like shock absorbing, but I don't think it's gonna actually hold up the weight. Okay, so we need to decrease the length, but this is like already super. It's already super tight, so I'm not sure this will damage the wire. Okay, that's worth testing out. So this gets us this much for the landing gear. I think that's decent. I don't think if we add more angle, it's gonna be a little bit tough, but still doable. I just don't want to adjust that too many times. Look at that. It locks into place. Would you look at that? Okay, maybe like a slight more. wire work, steel work, this kind of material, it takes a lot of patience to work with it. Okay, I think that's it. All right, now it's time to grab some elastic bands, which I should have some over here. Goodness, where did I put it? I swear I had like a bunch of elastic bands. Ah, they're right here. So, if you don't know about me, when I was a kid, I had braces. So you had these elastic bands that you had to use, and you had braces to keep your, to correct overbite and things like that. So this is where I get all my little elastic pieces. These, if you don't have these are very cheap, right? Again, you know, I want to make this accessible to most people, but if you don't have these little rubber bands, you should go buy some, because they're a fundamental component to these moving pieces, right? They add a little bit of pretension, which enables certain types of mechanisms. So this is really something that you can't escape. Like there's no substitute for it, right? Hinges you can substitute with wires and things like that, but when it comes to it freaking works. Oh my god, look at that. Yeah, but when it comes to like rubber bands and things like that, you can't really replace it. It's a material property. So there we go. That's my answer. But damn, that works so well. Look at that. Once we make this fold, it'll work. It'll pop out, and so look, it'll be like that, and then the white bit will just want to pop out. Okay, so it might be a little bit too strong, so I might have to remove one elastic band, but you get the idea. Right? It pops out like that, and then we're all set to go. That might actually be a little bit too much tension. Not too sure. But if we put like a... Oh, actually it might not be enough, because we have a huge lever arm here, so when we land, it's going to be like, and crash down and then compress this. I don't know if the weight is enough, but then again, we have 3 of these. So this is why landing gear are perhaps the most complicated thing about an airplane to design, right? Not only are you constrained by where along the planform you can place it, like here, here, and here, you're also constrained by material properties, right? Geometries, landing gear height, things like that. So it's a pretty complex system to design. But I don't work at an airframe company, unfortunately, so I don't have much experience or insight into this. But I don't know. This is a start, I guess. Yeah, so now the question is, how long do I want this leg to be? If you're a reasonable person like me, you would refer to your design sketches here. So about as tall as this. That means right about here. That's so not precise at all. But maybe like 2 centimeters. Yeah, 2 centimeters is about good. And then we can have it wrap back in that little loop, right? But this is looking quite nice. One thing that we do want to correct for is what was I gonna say? Oh yeah, this needs to, so this elastic band right here needs to be at the tip of this white corner here. And the reason for that is that gives it the most leverage, right? Because if I land, I want this to be quite stiff. But yeah, it's gonna be a trade-off anyways. If this is really stiff, if the landing gear is very stiff, it absorbs a ton of shock. It's gonna be hard to keep within the hatch. So I'm not actually sure if I want to do that, but it's a thing. Look at that! Would you look at that? It freaking works! Unbelievable! My design actually works. Look at that! Just take a moment to appreciate this, right? Anyways. Okay. Alright, I think I'm gonna continue here and fold this down. I think these two elastic bands are enough. So I'm gonna try and finish this off here. Okay. This looks pretty good. Alright, and then so to make this a little bit easier, I'm gonna take off this these two elastic bands here. It's a little bit tough actually to get them off. You just pull them off like that. Perfect. Okay, so I'm just gonna straighten these guys out a little bit. Oh, that's not good. Yeah, okay, so that's not, here we go. So one of them actually broke, or is very close to breaking. So I'm gonna have to grab another one. That's the problem with these soft materials, is that it's not very predictable how it's gonna break, unlike metal and paper. And I guess paper is kind of soft, but that's not the point. The point is it's hard to predict, and you just want to be careful with what you put those materials through. Okay, so I think this is good. Alright, we're gonna, before we close this loop off, I'm gonna put on the two elastic bands here. Alright, yeah, that's the last one. It's on the paper. There we go, that's 1. And that's 2. There we go. Just gotta grab that and wrap around these 2 little pins that we designed back here. And we have our mechanism. Alright. Seems pretty decent. Wow. Again, moving parts, right? So here's a close-up view. Right, grabs onto those little loops there, loops of paperclip back there, and then it rotates along this rotational bearing, which is the coil, and then the front is just wrapped around, right, this white piece. So, okay, that looks good. And then we just need to measure, what, 2 centimeters, I think we said. So, I'm not actually sure. So I want to mount this on a popsicle stick because I think directly mounting it onto the soft fuselage isn't the best idea. We need something to really handle the impact. Right, so I don't know, something like this where it's like wrapped around, taped to heck, right? Just really secured in place. I think that might do the trick. But yeah, also because this this front bit with the white piece here, it wants to go through the surface itself. So you need something strong to handle that. Right, something to counter that force. And a paperclip is probably the best option for that. So probably gonna mount it on a paperclip and then do just a straight cut back here. If it's only one cut, it's pretty straightforward to do. It's not going to be too bad. But we do need to make sure that this is aligned with the front here, and then we tape the heck out of this. We compress it and really tightly wrap everything around. So in the case that we do this, oh shoot, all right, yeah, we lost it. If we do end up doing that, I think the angle is actually a little bit different if we end up doing that. Yeah, because there's a slight slope for the front one. I guess we could like stack extra layers of tape and things like that to account for that missing thickness. Maybe like a second popsicle stick layer here. But it's tunable, right? That's the most important bit. You can tune the thickness to adjust the final angle of this landing gear, so that's good. But yeah, let's get working on this 2 centimeter leg here. This is a really important bit of the design. Okay, we need our Sharpie marker and our thingamajig here. Alright, so It's gonna be like that. Just want to dry fit again, see one last time how it's gonna fit, right? So it's gonna be like that. Oh my god. See, this is why we need that thing, that popsicle stick base. Okay, yeah, 2 is enough. It doesn't feel like much, but it is enough. So, 2, 7 right here. Cap this real quick. Just hold that in place. And it's going to be a sharp bend this way. Okay, and then just hold that in place. I think that should be enough. But then, oh my goodness, yeah, it's rotating. Okay, looks like it's not going to be a skid. It's going to be like a round thing. Alright. Well, I mean, I guess that works. I mean, I guess, yeah, because at this level, I don't think it's going to do much of a difference. Make much of a difference. So, circle it is then. Okay, that's it. And then this is the final step for this landing gear, is to cut this. Well, I say final, but it's not really final, is it? It's never really the end. So for this, I'm just gonna bend it off like this. Use fatigue to break it off. And then that way it's not a sharp edge. Just close it up a little bit like that. twist it a little bit. Yeah, there we go. All right, we have our first landing gear done. Let's see how it fits. Ooh, yeah, that's a lot of force. Okay. Oh man, that looks beautiful. Damn. I just gotta build a cover for this thing after. Right, just compress this into a little box like that. A small footprint. And then this needs to be twisted a little bit. Account for that. This is so intricate. Look at that. We made this today in 2 hours. It only took 2 hours. We went from design to manufacturing to a fully working piece. I think that's pretty impressive. I'm just patting myself on the back at this point, but honestly, I did not expect such great results. Look at that. Now, next time, I think the plan, because we only have like a minute and a half left on this stream, but next time I'm going to securely attach it to this base here, a stiff material base, and then we can adjust the thickness here so that we can adjust the angle of this leg. And then once this is all said and done, then we can attach the whole assembly onto the lower side here. And then once that's done, we can build a cover for the center landing gear. We build a hatch, right? Need a little sliding hatch to let the mechanism deploy, and then build the fairing that goes down along here. And then after that, we gotta build 2 more of these landing gear. And then after that, we need 2 more vertical stabilizers, and then maybe some extra reinforcement here, and then we're all set. And then, you know, just some finishing details that would complete this aircraft design. But this has been months in the making. I mean, look at this part. Like, this tiny mechanical part, it actually works. And we spent a good amount of time today, 2 hours and 10 minutes, to really figure this out and build it. And it actually works. So that's pretty amazing if you ask me. But anyways, so that's gonna be it for me today. You know, this is some good progress, and next time we just gotta integrate the whole front landing gear. Oh, yeah, it's very springy. Next time we just gotta integrate the front landing gear together, add some thickness and whatnot to get it to stay at the right position, and then put that onto the airframe, build a fairing around it. And so that's kind of the next steps here. We're just taking it one step at a time, you know, just going through the design process here. But that's been it for me. Thanks for watching. Stay safe out there. I know cases are rising in the US again, so please stay home. Please work on your projects. Please stay safe. And I'll talk to you guys next week. If you have any questions, feel free to DM me on Instagram at ben.fellow, or just leave a comment here on the YouTube recording after the fact. All right, so yeah, talk to you guys next week. Thanks for watching.